So in 5.3, number 33, you have tan theta equals. Yes? Number 33, tan theta equals what? Hey Prince, what is tangent equal? You asked for number 33, so I just want you to be with us. Cotangent 45 plus what? Are you sure it's 20? Because I'm pretty sure there has to be an unknown in there. Is that a theta? Okay, that matters. Okay, but you know something about tangent and cotangent, yes? They're cofunctions. So, can you tell me what else does tangent equal? Look back. Look back on page 217. Justin, are you with me on page 217? Because this will definitely show up on your test Friday. What else is tangent theta equals? Green box at the very bottom. Let's look that again. Tangent theta, it's at the end, but tangent theta equals what? Cofunction. Cotangent, 90 minus theta. Yes? So can we rewrite tan theta as cotangent 90 minus theta? Yes or no? Yes. I mean, that's just tangent right there. So cotangent 90 minus theta equals cotangent 45 minus 2 theta. They are both cotangent, right? You see there's a cotangent here and a cotangent there. So what can you do with these parentheses?
Why does it become minus?
Oh, I'm sorry. That's just I didn't rewrite it. I was going with this one. Sorry. Okay. So now, what can we do to solve for theta? Put what on the same side? Ultimately, yes. But what do we have to do first? If you have cotangent of something and cotangent of something, what do those two somethings have to be? Equal to each other. So now I don't need to know anything about cotangent. They're both in the same trig function. So now you have 90 minus theta equals 45 plus 2 theta. And you simply solve theta equals. I'm going to subtract 45 and add a theta. I think I get 45 theta. 45 degrees really equals 3 theta. Divide by 3. Theta equals 15 degrees. I think that's all it's asking for. Yes, ma'am. You have to remember the two. I don't think I give you a tangent. But you need to be able to, if I say, use the cosine and sine sum identities to derive a formula for tangent, I would like to see your process through that.
But these cofunctions, I'm just confused about this.
Cofunctions have been around since chapter 1, chapter 2. Yes.
We did not finish solving the tangent. We did not finish.
Then we'll go off on the infinity.
We did not get to theta.
I added theta to both sides.
Oh,
And I subtracted 45. Sometimes I think I can go really quick. From pre-algebra going to every single step. Really? No. Because if something happens, can you find if it was a double angle? Yes. Yes, ma'am.
if you go for like either 41 or 45, how you do the tangent?
41 or 45 still in 5.3? No, it's 5.4. So 5.4, we're going to what number?
41.
41.
Yeah, I got some weird numbers as answers, but
Did I give you 41? I thought I wrote 44.
You did 41, 45.
on 5.3 it was 44, 47, 48.
Yeah.
Okay.
For the 41.
Alright, so in 5.4, does it matter which one you want? Do you want to just do 45? Doesn't matter. I don't know. Alright, so are you with me on page 230? Doing number 45, and it gives you cosine S equals negative 8/17, and cosine T equals negative 3/5. And they're both in quadrant 3. Okay, so, yeah, cosine's going to be negative. Okay, so what about your triangles for S? What's your triangle going to look like? 8 is here, 17 is here, not necessarily drawn to scale. When we find the other side length is 15. So what are we looking for?
Side.
I need to know, what is sine of angle S?
Negative 15.
Why is it negative? Cosine is negative. Because we're in quadrant 3. What about triangle for T? It's a 3, 4, 5. And I still drew. It doesn't matter. So what is sine of angle T? Negative 4/5. Okay, so can we find what is sine S plus T? So here we go. Let's write in different colors. So what is sine S plus T? Okay, so I'm going to write the formula out. So I have sine S cosine T plus, because I started writing something else and I don't like cosine T, sine T. Yes. And now you simply plug in sine S cosine T plus sine T cosine S. Now, if you were to happen to come up with something in your denominators not multiplying to get the same thing, something's wrong. Okay? So, negative and a negative, negative and a negative, everything's actually going to turn out to be positive. Okay? So, 15 times 3, 45, 17 times 5.
Oh,
Do what?
sorry. 85.
I think it has
I
the
was
end
doing
of
the
the 5.
numerator.
8 and 4, 32 over 85. We add those together. We should get something like 77 85ths. Woohoo! You're done with sine of S plus T. Then they want you to know, what is tangent S plus T? Okay? So I'm going to scroll. Actually, I'm not going to scroll. Because I'm going to use those same exact triangles I just drawn. Because what's the formula for tangent if I go over here and write it really small? Tan A plus B is simply tan A plus tan B tan B. Okay? So instead of A's and B's, this is S and T. Does it matter? No. Okay? So my S, my A, can you tell me what is tangent of S? You've already got the triangle drawn there. So it's opposite over adjacent, so it is 15 over opposite over adjacent is 8. Is it positive or negative? Positive because it's in quadrant 3. What is tangent of t? Opposite over adjacent is 4 over 3, and it's positive also. Okay, so when we're doing tangent, wrote that way too big, I simply need 15/8 plus 4/3 divided by 1 minus 15/8 times 4/3.
Common denominator.
Then the math starts. I do not want decimals. Okay? You need to know how to add fractions. Common denominators. 24. So what over 24? Can I go really fast? 45 24ths. 32 24ths. 77 over 24.
Wait. 15 times 4 is 60.
I didn't do 15 times 4. 8 times 3 is 24. 15 times 3, yeah. Now down here, I'm simply multiplying 15 times 4. Now I need 60 over 24. Oh, you know what? Whoa, stop. Stop. Before you multiply, what should you do?
24 over 24 is what 1 was, right?
What should, well, yes, but can I reduce? Should I reduce fractions before I multiply them? I like that idea.
What?
Do what?
Why do you need to reduce before you multiply?
Because I don't want big numbers on the denominator or the numerator and have to reduce later.
Okay.
I mean, it's just a good practice to get into. Yes. So can I reduce? 4 goes into 4 once, 4 goes into 8 twice, 3 goes into 3 once, 3 goes into 15 5. So what's 1 minus 5 halves? Or 2 over 2 minus 5 over 2? You got a negative 3 over 2. So now you have a fraction divided by another fraction. What do we do? Flip
Flip the
and
bottom number and multiply, reduce.
77 over 24 times negative 2/3. 2 goes into 2 once, 2 goes into 24 12 times. And I'm 99.9% sure 3 will not go into 77. 7 plus 7 is 14, and it won't. So we have 77. What? 12 times 3. 36. And is it positive or is it negative? So here I'm going to go right over here and write tangent S plus T equals negative 77 over 36. Then it asks you a third question. What quadrant is it in when we add S plus T? Now there's several things you got to think about. That's not really crazy. You start out, S is in quadrant 3, T is in quadrant 3, okay? But what happens when I add them together? I'm looking at these two answers that I just found. Sign is positive. Sign of S plus T is positive. But tangent is negative. So which quadrant is that going to be in? 2.
Wait, why is it tan S plus T negative? Because it's in quadrant 3.
It is, okay, S is in quadrant 3, tangent's positive. T is in quadrant 3, and it's positive. But when I add two angles together, it became more, it went around again, and it landed in quadrant 2 when I added those two angles together. It'd be like adding 190 plus 260. So it's 190 plus 260. They're both in quadrant 3, but when I add them together, meaning over there, which is well more than 360. Does that make sense? Yes, ma'am. Number 9. What's going on with number 9 in 5.4? All right, can we look at number 9? Ladies and gentlemen, are we looking at number 9? In 5.4 still? Number 9. It says, what is sine? It was, what, 5 pi over 12? Okay? So, I don't know what 5 pi over 12 is on my plate. What can I do to find out where it is?
Yeah.
You can simply convert it to degrees. I mean, ultimately, I'm looking at 3 and 4 give me 12, but then that ends up being 7 pi over 12, which is 60 plus 30, or 60 plus 45.
I think you break it up into radians, so it's like 5 or 6 plus pi over 4.
Yeah.
And then just did that, and then like, because I knew what 5 or 6 and pi over 4 were, and then just did that.
Yes, but some people don't think, I mean, because I immediately think pi over 3 and pi over 4. I don't know, but 6 and 4, common denominator is 12. Or 2 and 6. Well, only 2 will go in 6, but, so I knew it couldn't be that one. So I'm taking 5 pi over 12 and converting it. So 180 over pi. These are going to cancel. These reduce to be 12 will go into, let's just do 6. 6 goes into 12. 2 times 6 goes into 80. So this will reduce again. So it's 15. 5 times 15, I think is 75. So really this is asking me what is sine of 75 degrees. And then I'm working it just like I normally would. I'm doing a 45 and 30, which is the pi over 4 and the pi over 6. Do you have a question? Means you have square roots in it. Right? Exact value? Yeah. 40, yeah. And we'll get that exact same answer. We just haven't worked it out. So what formula are you going to use, Justin?
Yeah. Is it cosine theta equals, or do you want sine theta is like the cosine 90 minus theta?
Do we need its cofunction? Do you know what cosine 15 is? Can you break 75 down into something plus something or something minus something?
Yes.
Okay? That's what you need to do.
60 plus 15.
So do you know sine of 15 and cosine of 15?
Yes.
You do? The exact value of those?
No.
No. So break it down into something you know. Little hint, the only things you know are 0, 30, 45, 60, and 90.
35 and 40.
Could we do, or flip those?
This is number 9.
This is number 9.
Yeah.
What are we adding? Sine of what? Plus what?
Sine. I have pi over 6 plus pi over 4.
Okay, so pi over 6. Pi over 4 is what?
45.
45 degrees.
Oh, this is so hard.
Okay, well,
Yeah, that's what I did.
I thought the example said I was
Agreed.
Raise the radians.
okay. I mean, that you just made it harder by doing that. It still works the same way.
That's an example.
So I told you that.
Ultimately, do what you know how to do. Okay? If you don't know how to work through the example with radians, don't. And then what else? What's pi over 6? It's 30 degrees. no matter what you're doing, sine of 45 degrees is the exact same thing as sine of 45. Did I say that the same thing? Sine of 45 degrees is the same thing as sine of pi over 4. They're the same things. You have to do it the same way. So whether you understand radians or whether you do better in degrees, work with what you know. Work with what you're more comfortable with. So what's our formula going here? Cosine 30 plus okay, and your triangles. You have to have your triangles. Maybe you already remember.
Is it okay if we don't draw triangles every time?
Ultimately, you need to, top of the page and use the same ones for everything.
I mean, like,
Or you just remember.
I mean, I know that, especially for
45 has to be square. I don't draw that one every time.
And then if it's tangent, it's 45.
Because it's one.
Like, I know that. And a lot of times, usually I always draw, for 36 and 90,
I draw those just to make sure I'm going the right direction. Cosine 30 is what? Plus sine of 30 and cosine 45. So no matter whether you left them in radians or whether you converted them to degrees, you will get the exact same pieces in this line. What do you do next? You're multiplying fractions. Square root of 6 over 4 plus square root of 2 over 4. And I'm saving a step and just writing it once because it's all over 4. Okay. You will have some of those. Okay? And you will always have to be able to combine them with the 30, the 45, the 60, or the 90. Okay? Are we good? Did I just do that one?
Yes.
Whoa. Got circles and a circle.
Okay, I got it. Thank you. Can we like finish solving
All that's gonna do is get into crazy stuff.
how can this be
Because I need to rewrite it differently.
will we do that?
It's not gonna be helpful for our test. So I'm not gonna take the class time to do that. I'm sorry.
Is our test just point 1 through point 4?
Yes. This is the end of chapter 5 that we're gonna do. No, because we will touch them in calculus, but it's not crazy important that you need to get crazy. We will do this again. This is in calculus. We will do this.
Yeah.
Okay? And I will be expecting you to kind of remember it. Then we'll talk about double angle identities more. Then we'll talk about half angle identities more in calculus. But they're not immediately like crazy.
So which formulas do we need to know for the test?
You need to know sine and cosine A plus B.
What about the minus?
Plus or minus.
Plus or minus. And then what about
Tangent, the worst thing I'm going to do to you for tangent is say use the sine and cosine to derive a tangent function, A plus B, or A minus B. We've done it before. We did the A plus and the A minus, where we did.
Can we not just memorize it? Like you want us to break it down for me? Is that what you're gonna ask?
Can you?
that down here?
That's just what this is. But this was my tangent.
No, yeah, right.
But it was 24 because it's 77 over 24 times a negative 2/3. So I flipped and then I reduced. there's going to be some verifying on test. That was still here. So, that's what I would like to go back and look at a little bit. Because I know I don't do this one.
So you're talking about with the tangent thing, how sine equals b because it's sine over cosine. Okay.
Yes, and so you would write the sine equation over the cosine equation. And I don't remember if I give you the
Can we do one right now?
divide by cosine A, cosine B.
So you see number with
So I don't know that that's
that.
Can we do an example for verify since we've got just a few more minutes?
Yeah.
Sure.
Now, let's have our brains turned back a little bit to verifying. Let's do somewhat of, I don't know which ones are easier. Let's just do one. Cotangent squared theta divided by cosecant theta. Verify that that equals cosecant theta minus sine theta.
Are we doing it homework this week?
I'm gonna take this homework up, yes, before you leave.
Why is homework so
Because we haven't had a homework. We don't have very many grades. I don't know that I've taken up a single homework from you all quarters.
Is that same cotangent?
This is cotangent squared theta divided by cosecant theta equals cosecant theta minus sine theta. Somebody wants to tell me where you're going to start on this.
Should you go on the right or left side?
It completely is dependent on what you think the harder side is. I'm surprised you haven't worked with both sides. So what's one thing that you might do first? So you're going to start with the left side and change cotangent into what? Or cosine over sine? Okay, so we have cosine over sine. Cosine squared, right? Over sine squared.
Times sine over 1.
So I'm just gonna literally rewrite it. What's cosecant? Should I write cosecant different? What is it?
1 over sine. Well, if you're multiplying.
I'm not. I simply rewrote cotangent squared as cosine over sine. Simply rewrote cosecant as 1 over sine.
Wait. How did you get this one?
Is it cotangent simply cosine over sine?
Wait.
I did something.
Cosine.
Oh,
Sorry,
yes.
cotangent is cosine over sine. So cotangent squared, cosine squared over sine squared.
What about the bottom?
That's
Oh,
cosecant.
1 over sine. Oh, okay.
have cosine squared over sine squared times sine theta over 1. Can something reduce? A sign, the sign on top here, but only one of these signs in the denominator, right? This is a way to do it. I don't really want to do that. What are you getting at?
Oh.
Okay, where do we want to go? You want to break down cosine squared? What is how else do we write? 1 minus sine squared theta over sine theta.
So you made the sine to cosecant.
I don't want that to be cosecant.
And I did that.
Okay, 1 over sine is cosecant, yes. Right?
Because I saw there is a cosecant.
There is a cosecant, but you can't just make it that way.
I don't know why.
If you have 3 halves minus 5 halves, 3 halves minus 5 halves, is there a way to combine them?
I know what.
3 minus 5 over 2. So if you have this, could we go back to that and pull them apart? Is this really 1 over sine minus sine squared over sine? Can you do this over here in my thought bubble? 3 minus 5 divided by 2. Can you make it be 3 over 2 minus 5 over 2? So I can do that with sine. I have a common denominator that's sine. So it's really I can write as 1 over sine, sine squared over sine, which becomes what? Cosecant. One of these signs cancels minus sine, which equals that. Turning our brains. I do want your homework. We need to turn our brains back a little bit to verifying. No.